Hi guys, in today's video we're going to solve a cast diagram. So it says in the diagram below we're given a point P with coordinates x and 5. They're telling us that OP is 13 units. So this length is 13 units. So answer the questions below without using a calculator. So the first thing that we need to do is we need to determine x. So point P on the given diagram is x units away from the origin on the positive x-axis and 5 units away from the origin on the positive y-axis. So we can complete our right triangle. Before we continue, let's recall that this is a right triangle. So this becomes our adjacent side, this becomes our opposite side, and this becomes our hypotenuse. With respect to this angle, this is the adjacent because it's next to the angle. This is the opposite side because it's opposite the angle. And this is our hypotenuse because it's the longest side. Also this, if we apply our cast, we can see that all trig ratios are positive here. So all your x and y values will be positive. So to find the value of x, we can use Pythagoras theorem because this is a right triangle. We know the square of the hypotenuse is equals to the sum of the squares of the other two sides. So our hypotenuse is 13 squared. Our x value we don't know, plus our y value is 5 squared. So this is 169 is equals to x squared plus 25. Therefore x squared should be equals to 169 minus 25, which is equals to 144. Therefore x should be equals to plus minus the square root of 144, which is equals to positive 12, because as we've seen, all the x and y values, or the x and y value in the first quadrant are positive. So the next question wants us to find tan alpha. So tan alpha by definition, tan alpha is defined as opposite over adjacent. And in this case, the opposite is 5 and the adjacent is 12. Bearing in mind the acronym SOH CAH TOA, so tangent is the opposite of the adjacent, hence 5 over 12. The next question wants us to find sine squared theta plus cos squared theta. So sine squared theta can be written as, sine squared alpha can be written as sine alpha to the whole squared plus cos alpha to the whole squared. Now sine alpha by definition is opposite over the hypotenuse squared, plus cos alpha is the adjacent over the hypotenuse squared. Always remember that sine squared alpha can be written as sine alpha to the whole squared, and cos squared alpha can be written as cos alpha to the whole squared, hence this expression. So the opposite over the hypotenuse is 5 over 13 squared, plus the adjacent is 12 over 13 squared. So this can be written as 5 squared over 13 squared plus 12 squared over 13 squared. So the lowest common denominator is 13 squared here. So we can write this as 13 squared. And in the numerator, we have 5 squared plus 12 squared. 13 squared is 169. 5 squared is 25 plus 144. So this is 169 over 169, which is equals to 1. And the last question wants us to find sec of alpha. So sec of alpha, the way I remember it, we know that sec of alpha is a reciprocal trigonometric ratio, which is equals to 1 over cos alpha. The way I remember it is the c here. So if you have the c here, it means we're dealing with cos as a reciprocal, because the c's correspond. So let's first start by defining cos of alpha. Cos of alpha is equals to the adjacent over the hypotenuse, which is equals to 12 over 13. So therefore, because sec of alpha is the reciprocal, it means its value is going to be 13 over 12. Thanks for watching. See you in the next one.